Solve the following equations. In this slide, we have two quadratic equations, and I know that this one on the left will be quadratic because I already see a square here, and x is inside the set of parentheses. And over here on the right, r is being squared right here, so I know these are going to be quadratic. What's different about these equations is how I'm going to go about solving them. This equation on the left, I'm going to use the square root property. And that's because I have something being squared. In this case, it's a binomial being squared. And outside of this binomial squared, all I see are numbers in the equation. Everything else is a constant, so this negative 28. That's my clue. If I have something squared, a binomial squared, or even if it were just x squared, and outside of that square there are only numbers, you will use the square root property. So for this one, I want to immediately take the square root of both sides of the equation. And that's because the binomial squared is isolated. There are no numbers outside of this set of parentheses in the square on the left side of the equation. So this is an isolated binomial squared. So I can just go ahead and start taking the square root. And that will give me x minus 3, because the square and the square roots reduce away, equals plus or minus square root negative 28. Now before I go any further, I need to simplify this thing. It's just going to make life a lot easier. And I know that the negative will come out front as an I. And then I'm left with the square root of 28. And this is still going to have a plus or minus in front of it. So now I just need to simplify the square root of 28 if I can. And I can, because this breaks down into square root of 4 times the square root of 7, still with the I in front and a plus or minus. Finally, I know the square root of 4 is 2, so I'm going to call this 2i square root of 7 with a plus or minus in front of it. And this will come down for the ride, so this will be x minus 3 equals plus or minus 2i squared root of 7. Now for the last step, the directions say to solve. That means isolate the variable. We have not isolated x, so the final step here would be to add 3. And when you add 3 to both sides, this will zero out, that's fine. But if you're going to add a term to another term that already has a plus and minus, the suggestion is to put it in front of the plus or minus. So the final answer here looks like this: x equals 3 plus or minus 2i square root of 7. In this next example, 7r equals 3 minus 6r squared, you can see that there's something being squared here, but outside of this one term, there's a constant and another term with a variable. So because we have this extra term over here with a variable, we will either need to use factoring or quadratic formula. Another thing to keep in mind before we figure out which method to use is that you want to have a positive a value. And the a value is the number that is in front of the variable squared. So this negative 6, I want to move that to the left side of the equation so that it becomes a positive 6r. And I also need to move this 3 to the left side as well, because if you can see an a b, and a c, you need an equal 0 before we can start solving. So let me rewrite this equation with all of these terms on the left. Alright, so here's the new equation, and it looks like factoring will be allowable here. And I can tell that because I can multiply my a times my c and get AC is negative 18. And I have B is positive 7. And so that leads me to the two numbers, 9 times negative 2 and 9 plus a negative 2. So 9 and negative 2 are how I'm going to split B here. So this will give me 6r squared minus 2r plus 9r minus 3 equals 0. You can group up the first two terms in common factor. You can group up the last two terms in common factor and continue the factoring process, which brings it down to 3r minus 1 times 2r plus 3. And then because of the zero product property, we can set each one of these equal to 0. So 3r minus 1 equals 0. And this one, 2r plus 3 equals 0. We can solve each one for x. Here we'll add 1. Here we'll subtract 3. And those 0 out and those 0 out, leaving you with these two equations. And then to find the final answers, you can divide by the coefficient of r. Oops, here it's 2. And you'll get your final answers of r equals 1 over 3 and r equals negative 3 over 2. Solve the following equations. On this slide, we have two quadratic equations, and neither of them are going to use the square root property. Right? That's that idea, well, I see I have an x being squared, and outside of this, if I want to use the square root property, I can only have constants, so like a plus 4. But here is a minus 2x. This is not a constant, this involves a variable, so I cannot use the square root property here. And you can see on this side of the right equation that it looks like that you have something squared and a constant being multiplied and a constant being added, and the left side of the equation looks like it's telling you you can use the square root property, but you can't, because over on this side of the equation it's not just a constant, it is a negative 8x. There's an extra variable over here, so we won't be using the square root property for either of these. Let's see here. So for the first example, ax squared plus bx plus c equals 0. It's good, we have the equals 0 already. So it looks like we need to find two numbers that multiply to a times c is 4, and two numbers that add up to b, which is negative 2. Well, let's see here. A times c is positive 4. That means I'm going to have the same sign, so 1 and 4 or 2 and 2. Those are numbers I can multiply to get 4. All right, so let's see here. So they're both pairs are positive, so that means 1 plus 4 is positive 5. That's not going to work. Let's see, 2 plus 2 is 4. That's not going to work. We're trying to get negative 2 when we add them. Let's try negative numbers, like negative 1, negative 4, negative 2, negative 2. So negative 1 plus a negative 4 is negative 5. Well, that doesn't match. Okay, negative 2 plus negative 2 is negative 4. That doesn't match. That's it. We've exhausted all of our possible factoring pairs. We can't factor this. So we'll have to use the quadratic formula. With the quadratic formula, you still need an equal 0 over here, so this is good. But we are not going to try to factor this, so we have to do something else. And if you look at the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a equals x. This right here looks a little menacing, so we're going to figure out b squared minus 4ac first. I'm going to do that right here. So b squared minus 4ac is the same thing as writing negative 2 squared minus 4 times 1 times 4. So negative 2 to the second power is 4. Negative 4 times positive 1 times 4 is a negative 16, which is negative 12. So what we'll do with this is we will take it and put it right in here inside the square root. Everything else we can just start filling in the numbers. So let's write x equals negative plus or minus the square root all over, and then we'll get 2a here in a second. So let's see, b is negative 2, so I'm going to substitute that in there. B squared minus 4ac is negative 12, so we're just going to put that right in there. And 2 times a is 1. 2 times 1 is 2. And now it's time to simplify this monstrosity. The first thing you should do is simplify this square root. When you simplify the square root, the negative will come out front as an I. The 12 will break down into square root of 4 times square root of 3, and the square root of 4 ends up being 2. So this will be positive 2 plus or minus 2i square root of 2, all over 2. And then from here, it's just good to be in a habit of separating this fraction into two fractions. Because the denominator only has one term, you're allowed to do this. So this will look something like this. X equals 2 over 2 plus or minus 2i square root of 2 over 2. And then you can simplify each fraction individually. Now when you're doing this, it is important to remember that you can only simplify numbers that are outside of a square root. So for instance, these two 2's here can simplify, and these 2's here can simplify. So 2 divided by 2 gives you 1, plus or minus 2 divided by 2 gives you 1i square root of 2. So here's your answer for the left exercise. And for the right exercise, we need to do something very similar here. Like I said earlier, we can't use the square root property, so that means we will have to move this negative 8x to the left side. It'll look something like this. And you can go ahead and try finding your a, b, and c and try factoring this. I'm going to let you know right now that it will not factor. So you have to be able to identify a, b, and c. So here's a, here's b, here's c. And again, it will be a, b, and c as long as you have everything in descending order. So x squared, that's the biggest exponent. X to the first power, that's the next biggest exponent. No x's, or technically x to the 0 power. So we have to have it in this order to find a, b, and c. And from here, I will slowly reveal steps every 4 seconds or so. So you can pause the video, try it yourself, and you won't see the whole solution at once in 5 seconds. It'll just be a step after step after step. And here is your final answer after you split this into two fractions and simplify each fraction. On this slide, there are two examples of quadratic application problems. The first one reads, the length of a rectangle is 4 inches shorter than twice the width. Its area is 96 square inches. Write an equation expressing this relationship. Find the dimensions of the rectangle. How I like to think of this write an equation expressing this relationship has to do with how you read the first sentence, or wherever there is the dimensions being mentioned. So you can see the length of the rectangle, blah, 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 the width. The width comes second, so that is what's going to be my x. So width will equal x. How do I figure out what the length is? Well, that's going to require me to look at the rest of this stuff. 4 inches shorter than twice. And I like to think of this using the order of operations. There is a multiplication happening here. That's the twice part. And there is an addition here, or a subtraction, one of those two, when you see 4 inches shorter. So how I like to think of this is I can write the length using the multiplication first. So twice the width. Since I know width is x, twice the width will be 2x. And this other part here, the 4 inches shorter, that is going to be a subtraction because it's going to be shorter. But the subtraction or addition that is in this statement will always come after the variable. So it'll be minus 4 after the x. So we have the length is 2x minus 4 and the width is x. From here, we can find the dimensions of a rectangle if you can just keep in mind what the area of a rectangle is. So I have this rectangle. The area equals 96, and I like to write that inside the rectangle to remind myself that that is an area. And the width is x, and the length is 2x minus 4. It turns out, as you probably remember, that the area for a rectangle can be computed by multiplying length times width. And so if I just substitute all of the information over here, like a 96, length, 2x minus 4, width, x, I can set up an equation now. So the equation would be 96 is the area, the length is 2x minus 4, and the width is x. And now I know this doesn't look like a quadratic equation, but when we simplify both sides, which includes multiplying or distributing, then we will have a quadratic equation right here. 2x times x is 2x squared. 2x x times negative 4 is negative 4x. And then right here, this 96, I'm going to subtract it right away to the other side of the equation. So minus 96 equals 0. These types of questions, if you're left with something that's quadratic, in a quadratic application, you will most likely be able to factor. One thing I'm going to do to make this easier is divide all terms by 2. And I can do that because I'm only dividing by a number. So when we do that, you can see this equation turns into 0 equals x squared minus 2x minus 48. And if you factor this, you'll get 0 equals x minus 8 and x plus 6. So then from here, you can take each one of these factors, set it equal to 0, so x minus 8 equals 0, that tells me x equals 8, and solve like I did right here for the x equals 8, so x plus 6 equals 0, that means x equals negative 6. Now, one thing to keep in mind is that we are talking about finding the length of the side of a rectangle, find the dimensions. So length can't be negative. So that answer is no good. That means x will equal 8. This is our good answer. But does this answer what we are asked to do? We are asked to find the dimensions of the rectangle. Well, x equals 8, that's fine, that tells me the width. The width will equal 8. But to find out what the length is, I also need to substitute this 8 back over here and for this x. So it'll be 2 times 8 is 16. 16 minus 4 is 12. So my length is 12. And there are the answers for the dimensions of the rectangle. And with this next example, it's slightly different. It's giving you this little hint here that you have a rectangle and the width is 6 inches less than the length. So you can see that length here this time is the dimension that came second. So my length will be x, and my width will be x minus 6. And then we have this other piece of information here that says that the diagonal is 30 inches. So I'm going to go ahead and call this side the length, and I'm going to call this side the width, x minus 6. And we have 3 sides of a triangle. This means we will be using the Pythagorean Theorem. So the Pythagorean Theorem is a squared plus b squared equals c squared. And the a and b here will always be the legs that form the 90-degree angle. And c will be the hypotenuse, the third leg. So all we have to do is substitute these in the correct place. So I'll call this x squared plus x minus 6 squared equals 30 squared. So from here, all of this can be FOILed out if it needs to be FOILed, and new equation will look like this. Then some terms can be combined on the left, and I will also subtract 900 from both sides to get a new equation that looks like this. And then, like we did up here in this example, I want to divide everything by 2, and I can do that because I'm only dividing by a number, and this will give us an equation with smaller numbers that will be simpler to work with. And so the new equation here will be x squared minus 6x minus 432. And at this point, you should factor this, and I can give you a hint over here. The hint will be 18 plus negative 24 equals negative 6. And that you should use these two numbers here. You should use to split this b value right here if you're using split b. So after you do that and you get your factors, x plus 18 and x minus 24 equals 0, you can set each one equal to 0 and solve for x. This one would give you x equals negative 18, and this one would give you x equals positive 24. And again, because we're looking for distances, the negative 18 doesn't make any sense. So we're left with x equals 24. And so we're asked to find the dimensions of the rectangle. That means since x equals 24, the length will be 24. And since x equals 24, the width will be 24 minus 6, which is 18. So your final answers will be length equals 24 and width equals 18. On this slide, we have 2 more applications, and to keep this video shorter than it should be, I'm only going to work on this bottom one for now. This is a rectangular swimming pool, measures 40 by 60 feet. Later, a path of uniform width is built around the pool, and the perimeter of the rectangle formed by the pool and the path is 248 feet. Determine the width of the path. So when you see one like this, it's always good to draw a picture. So here, this is my pool. Let me make this a little bit authentic for everybody. Put some little waves in here. And now, we all know now that this is 40 by 60 feet. Later, there was another rectangle built around this one that we're going to call the path. And what's nice about this is that it's uniform, so the distance all the way around the pool is the same, so it's x, 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 x. Finally, we know that the perimeter of this larger rectangle is 248 feet. So I know the perimeter equals 2 times the length plus 2 times the width. And the perimeter is 248 feet equals 2 times, plus 2 times, we don't know the length or the width, but we can find the length or the width. We know the pool is 40 wide, but the pool with the path, we have to include this side of the path and this side of the path. Well, it turns out each path on the left and the right of the pool measures x. So if we add 40 and these two x's, we just get 40 plus 2x. And we can do the same thing for the length. The length of the pool is 60. The length of the entire rectangle is the length of the pool plus this little bit plus this little bit. That will be 60 plus 2x. And so let's go ahead and see what happens when we distribute these twos. We can say that this is what? 248 equals 120 plus 4x plus 80 plus 4x. We can combine some terms over here. So 120 and 80 is 200. 4 and 4 make 8x equals 248. Well, this isn't even a quadratic equation. This is just linear. So we can just solve for x like normal, like you have been doing. So 200, subtract 200 from both sides. That leaves you with a 48 equals 8x. You can divide both sides here by 8, and that tells you x equals 6. So that means the width of the path is 6 feet, all the way around.